What up, calculus students? 8A students. It's a review day. I'm sorry I'm not there. Missed two third and fourth periods actually in the last 2 weeks. But hopefully you'll have everything you need to feel confident, ready. Everything's going to be the same for today. You are just going to do a couple extra practice problems on linear approximations. Then you have a quiz, and we have a test next class. Your quiz is going to be online. So it will be graded automatically for you. We don't have to worry about grading quizzes and grading these. You'll get your score immediately. I'll tell you, the quiz is a little bit different than maybe other online quizzes. Test next class. Make sure you complete the AP Classroom review to prepare. The video is in my videos page. It's 32 questions, a little bit longer. It's all multiple choice. Even amounts of questions from each lesson. Do not neglect in studying any of the lessons. Don't show up not ready for the log X lesson that you guys had the no homework day on and had the group quiz on. Like, go back and do that homework, okay? Because a quarter of the questions on the test are going to be from that lesson. AP Classroom Review, again, is available. Only 50% of students, probably less than that, did the Unit 3 review. So, I mean, I know it's like the second 9 weeks, and I know like efforts usually diminish throughout the course of the year, but this is not the test to do that for. Looking back at last 2 years ago, where they didn't cheat, more comparable to you guys, the average was a 72. 3 years ago, the average was a 71. Okay, 4 years ago, the average was a 71. Uh, so you gotta bring your A game. This is tricky stuff. 2 lessons, e to the x and log x, that reviewed everything, and then 2 new lessons: inverse derivatives, linear approximations. So let's get ready for the linear approximations quiz. I'm going to open it up to you to do in the middle of your class period. So you won't be able to like start right now. And here's how it's set up, just so you have a heads up. This was to prevent cheating last year, and it's also to prevent cheating this year. So it'll be in your Unit 4 folder, and you're going to see this quiz 44, and you're going to have a different version than anybody else has. And just the way that it's set up. I'll show you. You might see one question. There's the settings. You don't have the answer choices. So you only get to see one question at a time. The questions are going to be in random order, so you'll never have the same question as somebody else. You will not be able to review your answers. Okay. Now this is different, where it's like, oh, you get through all the questions and going forwards and backwards. Like, I'm not letting you go forwards and backwards. You do one question at a time, and you got to get the correct answer to that question. So this whole question review, it's like you go finish your quiz and then go back and check things. You're not allowed to do that. Okay, I found that's when students cheated the most last year, is they would just like kind of skip all the way to the question review. So even if things were in random order, they could get all the questions all at once, and then they'd compare it to their neighbors. So not letting you guys do that. So random order, one question at a time. You got to make sure you get that question correct before you go to the next question. You have unlimited time for it, so that's good. Last year, there was a time limit. Obviously, the sub is going to be walking around making sure you guys are not using any alternate resources, though they shouldn't help you. The resources that I don't want you to use is each other, okay? This is an individual quiz. Your work you're going to do on a piece of paper, you're going to submit it into your tray, okay? So that's what the quiz is going to look like. Be prepared for that. All right. I think there's 9 questions on the quiz. Now, make sure you pay for the AP test. Everybody's signed up, but you have to pay. I reminded you guys on Tuesday, and Wednesday. But make sure you pay for the AP test. Now we're just gonna do the practice problems. I'm gonna put up what your paper copy of the quiz was going to be, as well as its answer key on the website as well, so that you can do that. Like if you're like, oh, Mr. Messer, this wasn't fair. Well, everybody's doing a electronic version of this quiz, just like you did on the last quiz. It's like it's fair, and you had to do it. But if you want practice on a paper version, because that's what your test is going to be, a paper version, well, then you'll find it in the Unit 4 folder as well. Okay? All right, here we go. Linear approximations. So linear approximations are all about how we can, have some sort of function that curves. But if we zoom in on any point, we see that curves become lines. It's called a local linearization. And if we have a tangent line at a point, that tangent line, when we zoom in on both, is going to mimic that function. What that enables us to do is find very, very good approximations for some function values that are very, very tough to do by hand. For example, 2.1 cubed. I don't want you to take 2.1 and multiply it by itself 3 times. It says find a linear approximation. Okay. Now, typically for your quiz, I give you a little help. I'm going to say, centered at x equals 2. That way, like, for the graph of x cubed, you want to look at this point 2, wherever it is, and you want the equation of that tangent line there. Okay, so I'm going to give you a couple minutes to do this, and then you're going to answer the question whether it is over or under, and then why. And you know what? I'm not going to take a pause right here. I want the instructor, the sub today, go ahead and just like hit the pause button, press the space bar to pause, let the kids do it, and then when all the kids have agreed, like, hey, can we see the answer? You can press play. That way I don't waste time just like sitting here. Okay, cool. So you paused. Now we're playing. Let's go. We need the point and the slope. So the point is 2, 8. How do I know it's 2, 8? You plug in 2, you get 8, right? We need the slope. We need the derivative. The tangent slope generated 3x squared at 2 is 12. So the slope of that line is 12. So I get y minus 8 is going to mimic equals 12 times x minus 2 is going to mimic x cubed around x equals 2. So if I want to approximate what 2.1 cubed is, I will plug in 2.1 for x. Subtract 2 times 12. You're multiplying something by 0.1. Smooth the decimal place over. And I get that. 2.1 cubed is going to be around 9.2. Now, will it equal 9.2? No. This is an approximation. Okay? This is not the value. There are some questions, and you had it on your homework, where it's like, what could be the value? 9.2 is not the value. Okay? 9.2 is an approximation. But what could be the value of 2.1 cubed? Well, again, don't start doing 2.1 times 2.1 times. No. This is where we can look at the curvature of our function and realize if our approximation is over or under the actual. Now, I kind of gave you the sketch of y equals x cubed here. You could see this tangent line, points on the tangent line, no matter how close we are going to be below points on the curve. So I know this is an under approximation. Now, let's say you didn't know what the graph of x cubed looks like. How do you determine that? Well, you look at the signs of your second derivative. F double prime is 6x. It has a 0 at 0. F double prime is positive on the interval from 2 to 2.1. That means f prime is increasing. When f prime's increasing, f is concave up. Okay? If your graph any graph has concavity that's concave up. Okay, this is the graph of f. Draw a tangent line anywhere. Doesn't matter where it is, anywhere. The points on that line, on those lines, are always below the points on your function. Okay, so you analyze the second derivative, you determine the concavity. We know this is an under approximation, so what could be the value? I don't know, something bigger than 9.2. Maybe it's 9.3. Maybe it's 9.25. That would be an answer that I would circle if somebody's asking you, hey, out of these options, which one could be the value? If they say, hey, what's the approximation using a linear approximation? That's my approximation using a tangent. Hope you understand that. Talk to each other, talk to your neighbors about what I mean by that, uh, based on like maybe the homework problems that you got when we do the next problem. Okay, same deal. So approximate negative 0.75, and is it over or under? Obviously, you should center this, and I'll tell you like using a tangent line. And this is on your quiz. Um, Centered at x equals -1. Okay, let's go ahead and pause. You guys do the problem. Tell the sub when you're ready to see the answer. All right. I'm just gonna not even try to sketch this. I'm gonna plug in -1 to get the point. Again, -1 minus. This will be a +4 because it's -1 squared, so that's -5. -1. And now I need the tangent slope. Get the tangent slope generator. Plug in -1. And I get 11. It's 8 times -1, -8 minus -8. So the slope is 11. So I got y minus, or y plus 5 equals 11x plus 1. And now I want to approximate what is f of -0.75. Now, obviously, this is not going to be that great of an approximation because -0.75 is not super close to -1. Like the closer you get to the actual point that you know, the better your approximation and the better your line will do approximating the curve. So make sure we understand that. But still a good question. This is negative 0.25. And it's like, man, 11 times -0.25. Don't do that, right? Understand that a quarter can be written like that. This is a positive quarter. Why did I say -0.25? This is 0.25. I don't want to multiply 11 by 0.25. So I understand that that's the same as a quarter. Now, I'll have 11 fourths minus 5. 5 is 20 fourths. 11 fourths minus 20 fourths is -9 fourths. Okay, that's my approximation. Now, is this over or under the actual? Well, the only way I can tell is by looking at our second derivative in the concavity. I get 6x minus 8. 8/6, which is 4/3, is the second derivative, equal to 0. Positive and negative. X equals -0.75 is over here. So between -1 and -0.75, that means our second derivative is negative. That means my f prime is going down. That means f is concave down. Now, since the function is concave down, let's see. Draw something concave down. Draw any tangent line anywhere. Your points are over. This is an overestimate. It's an over approximation. The actual value would be less than that, which would be more negative. Okay. Going above means getting closer to 0. Going below would be more negative. So that's over the actual, the y value would have to be less than that. And, I'll just do this with my calculator just to double check. Now, you're not doing this with a calculator. The whole point of this is to not do it with a calculator. But negative 0.75 cubed minus 4 times negative 0.75 squared is negative 2.67. 9/4 is negative 2.25. Negative 2.25 is above negative 2.67. So this is my over approximation, just like I expected. Okay. Next question, popular question. It's to approximate a root, cube root, square root of some value. Now, you typically get hooked up on your quiz and on your test with like, hey, use this and use this and use a tangent line to this at this point. But let's see if you can figure out what would be the function that you would use and what would be the point that you would use. And then how would you approximate this? Okay. And our approximation is going to be pretty close to the actual. All right. Let's pause, see if you guys can figure it out. All right. If you didn't know where to start, let's maybe try again. Y equals the fourth root of x. I know 1/4 root pretty well. That's actually close to 15. I know that the fourth root of 16 is 2. I'm going to use the point 16.2 on the graph of the fourth root of x. All right. If you didn't do that, now start. Let's pause again. If this pause is worthless because you guys all figured it out, then keep playing. Okay, so I need the slope at this point 16.2 because this is like 2, 4, 8, 16. 2 to the fourth is 16. So the fourth root of 16 is 2. So I need the derivative. I got 1/4 x to the subtract 4/4, you get negative 3/4. Gross. Whatever. 1/4 x to the 3/4. Plug in 16. Ready? 1/4 times 16 to the 3/4. Okay, how do you do 16 to the 3/4? I would do the fourth root of 16 and then cube it. All right, the fourth root of 16 is 2. 2 cubed is 8. 2, 4, 8. Sometimes you guys are multiplying things together. So I have 1/4 times 8, which is 1/32. That's the slope of my line at 16. So my tangent equation, y minus 2 equals 1/32 x minus 16. Now, here's where people mess up. They try to plug in the fourth root of 15 for x. And they're like, what do I do now? That's not what you plug in. That's not what you plug in. Your equation is that. You're trying to approximate that equation with 15 plugged in. 15 being the x value plugged in gives you 15 to the 1/4. 15 to the 1/4 is the y value we're trying to approximate. So don't plug that in for x. We're going to approximate that y value. So what we want to approximate, and this is important for your quiz, approximate y of 15 by plugging in 15. And then we're going to add 2. This becomes negative 1/32 plus 2. This is 64 30-seconds. So this is 63 30-seconds. Okay, let me get the calculator out just so you can see it maybe a little bit better. Okay, so the fourth root of 15 is actually that. I found an approximation 63/32, which is very accurate. Has to deal with the slope being very shallow. It's not, the curvature is not great. Second derivative is not going to be a huge number either. All right, so that's approximating square roots, cube roots, all same process. Just make sure you understand what's going on. Last question. Approximating is zero. Talk to your neighbors about what's different about this. Approximating is zero compared to the other ones. And then of this function, knowing that we have the point 1, 1, approximate the zero's location. Okay, pause, and then we'll do it, and then you'll take your quiz. Unlimited time, one question at a time. You can't go back and check those questions. Okay? Okay. And subs walking around making sure you're not cheating. All right, so I need the slope of the tangent at 1, 1. So I'm going to find the derivative. Plug in 1. I get 3. Okay, so 1 plus 2. So giving me my y minus y1 equals m times x minus x1 equation. And now, a 0 is y is 0. When y is 0, what is x? So, y is 0. Solve for x. I'm going to distribute 3x minus 3. I'll add 3. I'll divide by 3. X equals 2/3. Okay. Let me give you one more. Give me a second. Okay, how about this? Ready? Just going to give you some info. F of 3 is 4. F prime of 3 is 5. F double prime positive. What could be the value of f of 4? Okay. Multiple choice. Seven, 8, 9, or 10. Which one? Okay, go ahead and try this out. Pause the video, and then I'll explain the answer. Okay. If I used a linear approximation, this would be my equation. Cool. And if I wanted to approximate f of 4, plug in 4, and I get 5 times 4 minus 3 plus 4. And that's 9. Okay. Here's what a lot of people do. They're like, okay, I got it. C. Wrong. Wrong. 9 is an approximation. What type of approximation is it? I mean, a linear approximation, sure, but is it over or under the actual? Well, you're told the second derivative of this function is positive. What does that tell you? F is concave up, curving upward. If you're curving upward and you use a line to approximate, then this value 9 is an under approximation, which means it's under the actual, which means 9 is not a possible value of f of 4. That's not f of 4. It's a good approximation for it, but I know it's not the value. What else can it be? 8, because 8 is below 9, and 9's already an under approximation. Can't be 7, because 7 is below 8, which is below 9, which is already an under approximation. So what is the only possible value you could get? My friends, 10. This is a problem that is seen always on tests that you need to be prepared for. Some questions ask you, what is the approximation? You would answer 9. Some questions ask you, what could be the value? And you would get the approximations 9, realize that that's an under approximation, and then be like, well, the actual value has to be something bigger than 9. You only give me one option of something bigger than 9, so that's it. I'll have quiz 4.4 and the answer key posted on Monday. Okay, on Monday. You guys have the unit review video, so you can do the AP Classroom over the weekend. Most of you probably won't, and you'll wait till Monday, and that's fine. It's just like, this is a tricky test if you don't study, because e to the x over everything, log x over everything, inverse derivatives, not super tricky, but a lot of people mess up on it. And log x you guys never learned in the first place because it's stupid no homework day. And then linear approximations. Not sometimes tricky. Okay, so please study, and I'll see you Tuesday for your test. Later. Email me with you if you have questions. I'll have access to my email.